All right, good morning, everyone. My name is Felipe Feijóo. I'll be chairing this session today. So I want to introduce Professor Sandro Nižetić. He's a full professor at the Faculty of Electrical Engineering, Mechanical Engineering, and Naval Architecture at the University of Split in Croatia. His research is in the field of thermodynamics, energy efficiency in buildings, smart technologies, and renewable energy sources. He has worked on various projects related to the implementation of energy efficiency measures in public buildings funded by the United Nations Development Program. He has also been the head of several national research projects funded in Croatia. He served as the deputy minister in the Ministry of Construction and Spatial Planning in the Croatian government, and as the vice dean of research at the Faculty of Electrical Engineering, Mechanical Engineering, and Naval Architecture at the University of Split. He's also the editor-in-chief of the journal Energy Sources Part A, associate editor in the Journal of Cleaner Production, and associate editor of Solar Energy Journal. Professor Nižetić has published over 200 research and conference papers, as well as several techno-economic professional case studies, and has visited several research universities and educational institutions worldwide as a visiting researcher or visiting lecturer. He has organized over 30 special issues in various journals. He served as the editorial board member in various reputable international journals such as Energy and Buildings, Cleaner Technology, and Environmental Policy, among others. For his research work, he received several major awards, including the Croatian State Prize for the Research in 2016 and 2021, as well as the Rector Prize for Research from the University of Split in 2018 and 2020. Based on the Stanford and Elsevier ranking list, he's among the top 2% of the world's top-cited scientists in 2018, 2020, 2021, and 2022 for a single year and overall career from 2021 onwards. Please join me in welcoming Professor Nižetić with a round of applause.
Hello to everyone. I hope that you can hear me. First of all, I would like to thank to Felipe for a nice introduction, and also I would like to thank to Neven and team for Italy for inviting me to the SDEWES conference. And I'm quite amazed to see such a lot of people here in city of Rome. So please allow me to deliver you today talk related to photovoltaic technologies, related to energy transition. I would like to go a little bit wider in order to tackle all key issues which are related to photovoltaic technologies. But please give me just a brief introduction in some key issues that are bothering us. SDEWES is a well-known conference, very much focused on energy transition, and we all know that present, I would like to say, economic system is not is unsustainable because population is rising. No matter that we have some regions of the world that have drop in population, overall globally population is rising, energy demands are rising each year. We have some issues with resources utilization, and it will become more and more intense. And finally, we are all facing environmental issues. Because of all these things, energy transition is respond, and I would also like to change highlight that change of bad habits is also response to be able to bridge all global issues. One of the key problems is that nowadays population is becoming, as I said, more and more intense, especially in the cities. Cities are becoming dense populated. We have problem with infrastructure, energy supply, life quality, security. Croatia is facing also big problems with tourism, especially in islands. When during the winter period you have maybe population 1,000, 1,500 people, while during the summer period you have 60,000 people on the island, and we have problem with infrastructure and also with energy supply, sometimes also problem with water supply. Finally, we have been developing quite fast, and this fast and unbalanced economic development has got a specific price that we are now paying, and it is reflected in environmental issues, climate change, waste issue, pollution. I'm not able to remember. I am 44 years old, and this whole August in my city of Split, during the night, temperatures were over 30 degrees of humidity was 80-90%. So I have felt that I am not anymore like I'm living somewhere in tropical area. When speaking about energy transition, we have 4 issues I think that should be carefully analyze and consider. First of all, you need to have political will. I was deputy minister, so I know how it was not easy to convince other colleagues because I came from engineering. I'm university professor, so engineers, we all want to set some problems. We would like to discuss what are the methods and finally some deadlines for solutions. But on the other side, and unfortunately, when you are speaking with typical people who are coming for political establishment, then we have a problem. Finally, if you have political will, then we are coming to funds. Sometimes there is a problem with funds, and do we have sufficient funds to address specific projects? Do we have sufficient technological solutions? Are we 100% sure that we have all which is ready and set to be able to have technological solutions that will drive energy transition? And we also need to have social acceptance. When I was working at UNDP project coordinator, the big problem was how to convince people how to implement specific renewable energy technologies. And this is also some breach which needs to be carefully addressed. It is not a matter of question that matter of urge that energy transition needs to be accelerated, which means regulation, advances in technologies, supply chains, and finally global workforce. We have problem in Croatia, especially in my region. We would like to install as much as possible a larger number of photovoltaics on the roof, but unfortunately we lack of companies in order to do that. So we need to also do quite a lot of efforts to establish companies who will be able to help to support installed PV capacity. Commitment to energy transition. Sometimes expectations are very straight, but reality can be very, I would like to say, stubborn. But no matter with that, some countries are faster, some countries are slower. I think that we are going in the directions where we are not able to go back anymore. And in any case, we should avoid later global actions because the climate will not wait for us. And I think that we are all aware of it. Now I would like to address the importance of photovoltaic technologies in energy transition. I remember it was, I think, 2010. Overall, it was like 62 gigawatts of installed PV capacities. Now, here we are contributing over 300 gigawatts, I mean in 2023. And of course, it's not surprised that majority of that is being installed and also produced in China. And overall, Solar accounted over 70% of renewable growth in last year, reaching over 1,400 gigawatts. Of course, after photovoltaic technologies, wind generation technologies are also very much important for an overall contribution of renewable energy capacity. Regarding the global cumulative PV installation, again, not surprise. China, then rest of Europe. And I think that without China, Europe would be not possible to reach energy transition goals, especially when we are speaking about photovoltaic installations. When we are speaking about renewable energy technologies, we need to take and to consider that without efficient energy storage technologies, it would be more or less very hard to manage renewable energy produced by photovoltaics, which means that regarding batteries further because time to environmental stability regarding production or production capacity should find materials. Sometimes we have problems with high they cost of energy. But we forecasting, then a significant drop in producing. Even forecast
Pri tome naravno i dalje sve je živo i dalje vidimo sve naše atribute s kojima smo ušli unutra. Dodatno možemo iskoristiti procesiranje uporabe, načina uporabe onako kako je evidentirano kroz katastar, složiti malo boje i vratiti se natrag na lider koje smo sada zamiješali sa digitalnim ortofotom, te on više nije samo klasificiran, nego smo mu dodali i RGB vrijednosti, dakle odvojili smo ga, te svaka naša točnica u prostoru sada je dodatno sadrži i RGB.
Okay, I will continue. If we look the cost of produced electricity, then we are coming to, and then it is very evident that PV electricity become very competitive with fossil electricity cost range, which means that if you have land, sufficient land, if you have some investment, you should invest in PV systems. If we compare PV technologies or overall costs of PV systems when we have started like 15 years ago, and now you can see significant drop in overall costs, but still one of the major costs is cost which is related to the PV panel, although now the cost of the PV panels has been quite reduced. And here you can see what are the typical prices of residential PV systems like in Germany, USA, in China. So we are ranging from 1,400 euro to a little bit up of 4,000 euros. So it all depends from country to country, but traditionally Europe and China are cheaper than USA. What we have regarding photovoltaic technologies, kind of state of the art, we have first generation typical silicon PV technologies. So those are crystalline silicon solar cells, then thin film technologies, and some emerging PVs. Oldest but the most reliable PV technologies are one made from silicon, so crystalline silicon solar cells. It is technology that we all know everything about it, and it is very much reliable. Then we are coming to the thin film technologies in various combinations. They are less expensive, but they have problem with lower efficiency. I will discuss a little bit more later. And some emerging like perovskite or organic solar cells, or some advanced concept that I will discuss a little bit later. This is current market share, 90-70% mono and multi, while now we have more produced monocrystalline and multicrystalline silicon PV panels, which was not, let's say, a question or state 10 years ago when we had the mostly multicrystalline silicon PV panels, because there was quite difference in price, 20-30%, although they were less efficient, but they were more, let's say, suitable for large-scale PV projects. This is current situation about annual PV production by technology. So mono, then multi and thin film, although I said 10 years ago, multi silicon-based technologies were most representative of the market. Now we are more focused to produce, to install systems who are as much as possible more efficient and more reliable. As I said at the beginning, China is leading regarding the PV capacities. I'm traveling each year 2 times, at least 2 times in China. And each time when I come, I see big difference. And nowadays they are installing without problem on the roofs 400, 500 kilowatts PV systems. I have even met some university professors who have companies that are installing PV systems. And I must confess, it's much more cheaper than Europe, much more cheaper than Europe. And we can see that in the first half of 2023, China increased export 30%. I think that this is very critical for Europe, because Europe is not standing so well regarding overall production capacities, and definitely we should increase this. When we look what is typical efficiency, now it's like between 15 to 23%, of course, overall, but in laboratory conditions, usually we are reaching 20%, while if we are in some real field situation, it will be usually somewhere between 14 to 18, 19%, depending from specific location. But what could be noticed is that in the last several years, nominal size of the PV panel, which was previously up to 300 watt is now without problem over 400 watts. And in the last few months, in my last visit in China, I have found out that they are producing PV panels all 500 watts per PV panel, which is quite big achievement. So we have basically double capacity. Again, production by region. Europe is not producing as should produce, mainly Asia, mainly China. When we see what is like a landscape in Europe, we have some companies that are producing. Croatia also has got a very nice company, SDEWES, which is exporting, producing, but still I think that it's not sufficient to reach these goals that we would like to reach. Of course, it's not just matter of production. We should have available raw materials to produce sufficient PV capacities. Let's speak about PV technologies to address some advantages or some characteristics. Monocrystalline are nowadays the most used. They are more expensive when compared to multicrystalline, but they are most used nowadays. They are more efficient, usually up to 20%. As I said, if you would like to go over 20%, then usually laboratory conditions, they have better efficiency, requires less space. But on the other side, they are more expensive because they have larger amount of wasted silicon during the production process. And they are less sensitive on temperature, on efficiency degradation during the period of elevated operating temperature, which is something which also needs to be considered because it is affecting overall PV system performance. Multicrystalline silicon PV panels, I said before, they were used quite frequently in the big PV systems. Now they are used less because they are less efficient, which means that they require more space. They are simple to produce and they are cheaper, but on the other side, they are most sensitive to the degradation of efficiency during elevated temperature, which is usually between 0.4 to 0.6% per degrees of Celsius. Thin film technologies, they are very nice because they are flexible. We can apply them on different curved geometries, which is sometimes target. You know, it is very easy when you have flat PV panel. But then on the other side, you have a limit because you can only put it on the flat surface. While if you have curved geometries, like as it is presented on these pictures, then you can apply thin film technologies. But they have quite low energy conversion efficiency. In realistic operation is usually below 10%. It's very simple to produce them. They have lowest impact on performance regarding the operating temperatures, but on the other side, they have high degradation, which means shortest warranty from producer. So I would like to say that selection of specific PV technology depends, of course, from your space constraints and funding options. This is some overview of thin film technologies. They had the peak during the 2006 and the 10, but now it's like just less than 3% of the market in cadmium telluride or copper indium gallium selenide option. Regarding new PV technologies, time to time you can see from media, from some portals which are linked with energy, that there are some breakthroughs like in discovery of photovoltaics with energy conversion efficiency over 40%. It's nice, but reality is that in majority of situations, these kind of technologies are still not ready for large-scale application. One of the technology which is very interesting is transparent PV technologies. We all have buildings, we have windows because we need to have windows because of light. So idea is why not to use windows as active producer of electricity. And this idea was born in USA. It was one very nice spin-off company. But the problem with transparent PV technology is quite low efficiency and high unit cost. I remember we had one case study several years ago for our university library. It's a building which is fully made of glass, like double skid facade. And I have made a contact with this company from USA to ask them some details and student made a project with transparent PV. panels, but when we have calculated LCOE, it was much more than LCOE from electricity from grid. So in those times, it wasn't reasonable to apply this technology. But from Australia, from Monash University, there are some signs that they have managed to increase energy conversion efficiency and come basically and become comparable with energy conversion efficiency from silicon PV panels, which means that they've managed to reach between 15 and 20% energy conversion efficiency. Now they are working how to apply this technology on the large scale. So this is something what is under investigation. We can also play with nanomaterials, nanopyral solar cells to increase the band gap, to increase light capturing, light absorbance. But of course, the problem with nanopillar is high production or manufacturing cost and also toxicity. When you are working with nanomaterials, there are quite high demands, high safety standards, which needs to be very much carefully considered and taken into account. What is the latest and the most interesting is combination. A few years ago, I also had one lecture, and the idea was born to combine silicon and perovskite, and Fraunhofer has done this. 2024, they managed to produce PV panel, tandem PV module, reaching efficiency 25%. I was not able to find in which conditions they have reached 25%. But the fact is that they are now certifying this PV module in 2024, and they will start, idea is to start to produce this PV panel on large scale. And one interesting thing is that they managed to create new encapsulation process, which is very important from perovskite, because perovskite are very sensitive on temperature and they can degrade very fast. Perovskite solar cells in the last few years, there was quite big jump in energy conversion efficiency. Even now we have some increase, but the problem with them is some issues which are linked with this long-term stability, because temperature unfortunately is affecting performance, because when you have PV panel, then you have this cycling, heating, cooling, which is of course affecting structure of material. Then there is a problem how to apply this technology on large scale. And finally, there are some environmental issues. Of course, I'm a fan of PVs, but I would also like to be aware that if we are using specific technology, especially if we have significant increase in capacities, we should think now to prevent later some environmental issues. So for perovskite, there is a use of organic solvent, toxic lead, which is now focus of the research community, how to produce perovskite without lead. The highest cell efficiency recorded, this is some very complex diagram in laboratory conditions. I would just like to say that multi-junction and perovskite are one that are reaching the highest efficiency, especially when you have concentrating solar cells. But on the other side, when you have concentrating solar cells, you have problem with heating, which means that you need to cool in order to be able to reach desired efficiency. So if we speak about those technologies that are on the market, that we are working with them and operating each day, still there are some issues. Overall high investment. This is something which is improving, I must confess, but you have unfortunately some countries when people don't have money to invest in PV systems, and this is a fact. This should be breached. Modest energy conversion efficiency, lower than 20%, but no matter with that, if you have land, why not to put PV systems? And of course, if we assume that we are on some specific location when we have sufficient solar characteristics. Usually there are issues with performance drop during elevated operating temperatures. I said before, above 50 degrees of Celsius, typical silicon PV panels are experiencing this performance drop. So if you have technology which is lower than 20% in energy conversion efficiency, this effect is also something which is affecting overall performance. Then performance drop during accumulated dirt when I was visiting this big PV system, 4 kilowatt in China, it was completely covered with dirt. And this is especially a problem in big cities when you have dust pollution or particulate matters. This is something which is affecting. Sometimes problem with batteries, inverters. You know, people when they are installing PV systems, if they have batteries, you need to tell them that they will need to change batteries. They will need to change inverters in the lifetime. In some countries, complicated legislation. Croatia was very demanding 15, 20 years ago, but now things are getting much better. And sometimes if we don't have sufficient grid or infrastructure in the grid, we have problems with integration. But all these things can be bridged. So what I would like to highlight is that we should work on efficiency improvement, further reducing the cost. Long-term performance is something which is desired to be fixed. Grid management and energy storage is something which is connected. And I think that in this matter, the most important thing is how we can use smart technologies to make systems, PV systems as a whole, smart. And one of the key issues what I would like also to address is something which is linked with environmental impacts and recycling. Of course, I said that I'm a fan of PVs, but also we are not able to neglect that if we are installing now 300 gigawatts, if in 2050, I think that we will have 4,000, 5,000 gigawatts of installed PVs, we also need to think about waste. PV panels are not waste that you can just throw like this. It has some toxic substances, which means that it needs to be carefully managed. And if we look who will be the major contributors, it is not surprised that China is leading because of installed capacities and production, then USA, Japan, India, and Germany. Typical production process of PV, of photovoltaics, is a high energy demand process, and also it is requiring water consumption because silicon wafers needs to be polished with large quantity of the waters. We are using some toxic materials in production: cadmium, lead, arsenic, selenium, and also some specific processes, production processes such as etching, doping, coating are creating volatile compounds, greenhouse gases, and some acid gases. So what we can do? Improvement in energy conversion efficiency. We should consider how to involve as much as possible renewable energy systems in production process and also water recycling process. This is must in the production of the PV processes. According to projections from International Renewable Energy Agency, about 6 million metric tons of each year will have PV waste. And USA recycling experiences that for standard 60-cell silicon PV panel, recycling cost is around 12 to 25 US dollars, with a revenue about $3 US, but cost to dump PV panel on the solid waste landfill is less than $1 US, which means that something is not good with our conventional recycling processes for photovoltaics. Estimation is that recycling market is a big market, at least 15 billion US dollars by 2015. And there is no doubt that PV recycling is important because we will recover some rare and valuable materials. Here on this slide, you can see typical recycling traditional processes when we are trying to utilize as much as possible useful materials as outputs for production of new PVs. What is the problem? In many countries, we don't have legislation or lack of sufficient infrastructure for recycling. So if you are producing, you need to think immediately how we will recycle. We don't have regulations, or they are not sufficient, they are inconsistent. Unfortunately, some PV panels are land up at the landfills, and if after a certain number of the years, they can potentially leach some toxic material in the environmental, and they can contaminate soil and finally water. So there is urgent need to improve waste management and recycling processes for conventional PVs. And there is recently one nice idea, which is something which is, I think, has got linkage with this Musk idea of reuse of batteries, reuse of PV panels. So after 25 years, PV panel, of course, he will have reduced PV panel output. But on the other side, this PV panel is still working. So idea is why not to take this kind of PV panels and to reuse them on suitable areas, because still they will produce some electricity, and then to buy some time until we will create better recycling processes. I must say also that no matter that I'm a fan of photovoltaics, they are covering large areas by installations, and we have sometimes problem with land use, agriculture to produce food or forestry. So this is something which needs to be carefully considered and try basically to avoid all these high sensitive areas for installation of the PV systems, because we can have some impacts regarding local increase in temperature, light impacts on the bird, insects, and other species in the nature. So what are the possible improvements? What we can do further? First step is try to simplify production processes as much as possible. Try to use less energy, try to involve more renewable energy systems in the production. Try to create better wastewater treatment system in the production of photovoltaics. Reduction in the material consumption, mainly silicon, but if you compare when we have started to produce silicon PV panels, and now we have reduced more than half quantity of this silicon, so which means that we have already made quite efforts. Further efficiency increase monocrystalline silicon technologies, because they are now mainly used, so try to achieve increase efficiency. Further price reduction of specific electronic components. This is also welcome, because electronic components, especially inverters and batteries, if we have battery PV systems, are affecting overall costs. Diagnostic of the PV systems and monitoring is very important. When I was in China, my last visit, there was a big PV system, very new, but there was a problem with installation. System was not installed well, but professor from university, he's dealing with photovoltaics, and he discovered what was the problem. Unfortunately, the problem was that company that was installing PVs, they were not aware that they have made the problem which can cause a fire of the overall PV system in the less than 2 years. So this is something which needs to be carefully taken into account, better diagnostics. We should also investigate new potential application areas of PVs. We are limited. We have some new, relatively new areas I will discuss a little bit later, but still we should maybe think outside of the box, more creative where and how we can apply and implement PVs. And finally, development of the efficient and economically viable autonomous like cleaning systems, like drone or robotic cleaning systems for PVs is very much also welcome in this region when there is a problem with dust or PM or particular matters. One strategy is how we can increase efficiency, how we can increase lifetime of the PV panel, how we can reduce degradation is to cool PV panels. Each time when PV panel is being exposed to the sunlight, we have cycles, heating, cooling, heating, cooling. Those cycles are affecting silicon, affecting crystal structure, affecting light absorbance. And proper cooling can help to, as I said, improve efficiency and also to improve lifetime. We have passive cooling methods, active cooling methods, passive like attached heat sinks, thermoelectric, liquid immersion, etc. Active, direct, indirect water, air force, or nanofluid. Passive are usually very cheap for installation. They don't desire, they are very also easy for maintenance. But on the other side, we need to be aware that they have less improvement in performance when compared to the active cooling techniques. On the other side, active cooling techniques they are consuming energy to operate specific cooling techniques, which means that we need to be very careful in design in order not to come to the situation that we have increase in the performance, but on the other side, our increase in performance was eaten by consumed and operational energy to manage this kind of cooling techniques. Just a few brief overview of passive cooling techniques. Liquid immersion, very nice. You can float PV panels, but the problem with floating of PV panels, you have something which is electricity float in the water. Sometimes there are problems with sealing, and also if you are going too deep, you have problem with optical losses. There was one nice study of photovoltaics put in the swimming pool, but outcome of study was that because of optical losses, of course, production was not on the level that it should be. Then we can have some like heat sinks, like aluminum fins. This is something what we have done at my university, very cheap, up to 5% you can achieve energy conversion efficiency, or thermoelectric, quite expensive, or you can even use phase change materials, but use of phase change materials is of course problem because phase change materials are quite expensive, between 4 and let's say 15 euro per kilogram. Then we have problem later how to manage heat transfer because they have thermal inertia, so we are playing with heat sinks. But in any way, application of PCM should be always in combination with active cooling systems. So by passive cooling approach, we can also play with PV panels or try to change conventional architecture of the photovoltaic panels. We were doing this ideas to put some slits to increase heat convection. There was one study they put the holes, but of course you are affecting standard production process, which can cause increase in the cost. No matter if we summarize passive cooling techniques, let's say 3 to 15% performance improvement and around 5 to 20 degrees is reduction of the panel operating temperature. Active cooling approaches are of course more effective. Usually we are using water over the PV panel, front or even back side. It can be even done on a box. This middle PV panel was produced at the University of Catania. They have put polycarbonate box on the front surface of the PV panel, so it was like Italian product. Or we can use instead of water air, but of course it is much better to use water because water has got better thermal properties than air, and we have played with different kind of absorbers in order to increase performance. Usually when we are speaking about active cooling approaches, then we would like to use this waste heat from the PV panel as to preheat the water or to heat the water, and which is of course reasonable. We can even use the nanofluids. The problem with nanofluids is that, again, we are doing with toxic materials. It's not easy to produce nanofluid. There is a problem with also long-term stability of nanofluids because preparation process is later defining long-term stability. But what we need to be aware that we can improve thermal conductivity while latent heat and specific heat capacity can be a little bit improved, or even we can have some reduction depending from the type of nanomaterial. If we summarize again active cooling approaches, efficiency and performance can go up to 30%, but as I said, very important is to be careful what is the or how much of operational energy we are using to manage these cooling techniques. This is successful example from Portugal. It was PV panel system, 5 kilowatts, cooled by sprinkles, so it was cooled actively by water. And they have managed to increase annual performance around 12%. Payback time was 2 years, and revenue depending from location, it was, I think, Lisbon and Porto, between 17 and 20,000 US dollars. What is the idea? What is the message? The message is yes, active cooling can be economically viable, but it needs to be carefully designed in order not to have system which is consuming more energy that can achieve increase in the performance. PVT systems, When we are speaking about photovoltaic technologies, I must also tackle here PVT systems, because in the recent years, we were not so interested in PVT systems, and now the situation is a little bit changed, because we need to increase renewable energy capacity. So again, PVT systems are coming also in the focus. They are very nice because on the same area you can produce thermal and electricity, but electrical efficiency is usually less than 20%, while thermal efficiency can go even over 70%. Problem is with this PVT system, cost is like between 300 to 500 euro on average. Of course, you can have more expensive PV panels, PVT collectors, and relatively low producer warranty. Usually it's like up to 10 years. And if you are producing PVT collectors, you have a problem, because you, on one side, you would like to produce hot water. On the other side, you would like to produce electricity. If you are overheating PV panel, you are reducing electricity production. And of course, if you are reducing temperature of the PV panel, you will produce more electricity, but you will have a lower water temperature. So design of PVT panels is very important, and we have quite large application area, from domestic hot water, process heat, drying, residential heating systems with concentration. CPVT, we can reach temperatures over 80 degrees of Celsius. The problem with the PVT systems is high unit cost of the PVT collector. So this is something where research community should be more focused. So how to produce more efficient PVT collector designs? When I say more efficient, then I mainly think about absorbers. So absorbers needs to be in the focus for specific application. My team was doing quite a lot of research regarding PVT PCM collectors. So we also made some review regarding the type of the PCMs, PV cells, insulation, types of the tubes. And the idea is, of course, to have uniform cooling of the PVT panel, and also to think about that we need to create a system which is flexible regarding the desired electricity power output and also desired thermal power output. We have done one study with PVT collector with pork fat. Pork fat is a cheap material, organic phase change material, which has a little bit lower thermal properties than, let's say, conventional PCM materials. But on the other side, pork fat after 1 year become waste. We are throwing it, so why not try to consider it not just for this kind of purpose? It can be also considered for some other properties, for some other applications. And now what we are basically doing, we have a project, and we are trying to produce waste-based phase change composites made from waste materials in order to find suitable combination for specific applications. Regarding the PVs, I said that we should increase PV capacities, which means that sometimes you have countries which have limited surface, because you need to have surface for agriculture, production, forestry, but also you need now to book some surface for PVs. This well-known GCR report has addressed how much of terawatts of PVs we need to have in Europe, which means that we need to discuss, okay, we need to consider some other opportunities and how to smart use land. Then we came to the floating PV plants, which is something which is already well known. But unfortunately, Europe is somehow shy. The majority of installed capacity is in Asian region, Japan, China. And this market, according to projection, will become more and more interesting. So around 2032, it will be over $45 billion. So this market is, at least the projection is that it will be increased. And why floating photovoltaics are good? Because they can increase cooling effect by evaporation, because evaporation is helping PV panels to release heat. They are reducing growth of algae. Reflectivity is also helping to increase performance. But on the other side, we have some problems with maintenance, especially if you are on the sea surface. It's not like in the lakes. Then we have problem with an environment, and also we have problem with labor workforce who will manage this kind of the systems. Do we have some negative impacts of floating photovoltaic plants? Fraunhofer made one study very recently. It was floating PV system in Lake Mainwald in Germany. It's like a little bit over 700 kilowatts. And they have noticed that there is some impact on the water temperature, not so significant, but up to range to 5 meters. If you are going deeper, then we don't have significant impact of floating photovoltaic plants. But what they have noticed is that PV structure, especially if it is big one, is affecting wind flow over the lake. And it can cause locally increase in water temperature because, you know, like in my country, usually during the summer, we have very nice west wind, which is a natural blower, and it is cooling sea. Like in the case of photovoltaics, we should consider and we should make more investigation. This is also a very nice research topic, how PV systems are interacting with sea or with lake surface and how it is affecting cooling of the PVs. In any case, this is something that should be focused on the future research efforts. Another thing with photovoltaics is problem with sudden phenomena like typhoons. This is Yamakura Dam floating PV installation. You have seen this from the media, but we also must confess that this was abnormal with speeds, you know. What was the problem? Engineers had to make standard technical assumptions, and because of this, and because of lack of specific structural codes for floating photovoltaics, there was problem with anchorage, and they have failed, and then we had this problem. So this is also something which should be considered in the future, how to produce standards and how the standards would look like to prevent this kind of events, because we are not able to avoid them. Agrivoltaics are very interesting, again, new or relatively new application areas. Why? Because we can have very favorable microclimate effect on the crops. In this slide, you can see some crops, how shading is helping to increase productivity of the photovoltaics, or specific crop is increasing productivity of photovoltaics, which means better water management and finally improved economy. But there is one restriction. Restriction is that we can only use shade tolerant crops because some crops are not able to be not exposed directly to the sun. There is a problem with maintenance. Farmers need to have special kind of the tools, and they need to be educated special machinery in order to be able to manage this kind of systems. In any case, I think that agrivoltaics are very important, because now, beside energy issue, we also need to be very much consider about food issue. So food production and safety of food production is something what we should consider. Croatia had damage in period 2013-2018, almost 2 billion euro due to climate change, droughts, ice hail, and there is evident decrease in yields of agricultural crops between 3 to 8% annually. This is a case of Croatia. This year, for instance, the Croatian wine producers started never earlier harvest of wine grapes, almost 1 month before, because of high solar insolation. So agrivoltaics can help to increase production of food and to achieve food safety. Finally, again, I'm asking myself, because if I would eat tomorrow something that was grown up before below photovoltaics, do we have some climate, do we have some environmental impact of agrivoltaics? LCA was made for case of Germany, and the conclusion was that we have significant environmental benefits growing photovoltaics by agrivoltaics. There are some impacts regarding because of use of mineral and metals, but when you took overall aspect was positive, which means that we could increase number of agrivoltaics in any case. So finally, because I think that I'm now 45 minutes, so I should be come to the conclusion sections. What we can conclude? First of all, the most present market PV technologies are silicon-based technologies. Why? Reliable, energy cohesion efficiency is below 20%, which we can say that it's not big one like modest, but no matter if you have land, if you have solar characteristics, area with good solar characteristics, there is no issue to install PV systems. There is a necessity to increase energy cohesion efficiency, especially for those that we are using now, like monocrystal silicon. The cost of produce electricity from PVs is competitive now with cost of energy or electricity produced from fossil fuels. What is the problem with PVs? I think for me in the long terms is this recycling process. We must improve it. We must have better regulation, and we must involve renewable energy systems in recycling process. How we can additionally increase performance of silicon-based technology? We can cool, as I said, and especially in the PVT systems, because when you have usual demands, what you need usually electricity and hot water. Of course, nowadays we need cooling. We need also cooling. And regarding the novel photovoltaic technologies, perovskite, try to remove lead. We will have and try to also secure perovskite on large scale, which means that we are not dealing with small produced PVs. This is welcome. And one of the problems is environmental suitability of perovskite technologies, which is, as I said, something which needs to be done. But when you are speaking with colleagues who are working with perovskite, they are claiming that metal halide and some hybrid solutions like perovskite plus silicon, which Fraunhofer has approved, is the way where maybe we should go in the future as a step further in order to try to produce something which is reliable as conventional silicon-based photovoltaics. Further efforts, we should think outside of the box, above floating photovoltaics, above agri-photovoltaics, how we can find some new application areas for PVs. Regarding the floating photovoltaics, I have raised the question that more research efforts should be done to see what is interaction. Just to know, when we are applying over some lake, when there is some lake which is very sensitive regarding nature, to be sure that we will not cause long-term damage. Resilience to climate change of photovoltaics, something which needs to be considered, but not just photovoltaics. Recently, there was a big typhoon in China, and you saw in this island that was affected, wind turbines was broken like peas. So this is something which should be also considered into account. How we can do and how we can secure resilience for our PV systems. And my final message is that EU, if EU would like to reach targets according to Paris Climate Agreement and also GCR targets, we need to produce, we need to increase production of the PV capacities, and also EU needs to consider more tight collaboration with China, because China has got large production capacities, and we will not be able, even with increased EU capacities, I'm not sure that we will be able to reach all these demands if we will not have collaboration regarding production of photovoltaics. And that's it. I came to the end. Thank you for your attention.
So we have time for a couple of questions. Professor Deutsch. Yeah, end the show. You have the.
So we're now coming to the times when duck curve is slowly becoming a canyon curve. So one of the major barriers to fast further penetration of solar is integration. So we have to solve that issue. That's one half question. Another one is locally what happens when you have too much of solar. There is problem with ancillary services. A voltage falls down and then it turns off. So we need to start installing grid forming inverters. How do you see those two processes going on?
I think that first of all, this first question, which is which Neven you have tackled, the main issue is proper labor force. You know, we need to have sufficient skilled people who are ready to install PV capacities. But unfortunately, I'm aware quite a lot of recently a lot of situations, at least in my region where I live, when unqualified people are installing photovoltaics. They are damaging photovoltaics. Because of this damage, tomorrow you have a problem with potential fire. And then you are creating negative picture about technology, but core of the problem was improper installation. So without skillful, I would like to say, and professional companies, we would not be able to reach those targets. And I think that this is now narrow road. Regarding the second part of the question, there is no doubt that the grid need to be adapted. Otherwise, you know, we will not be able to manage such a large number of photovoltaics. And I fully agree that this is something which needs to be done on parallel way. Otherwise, I'm not seeing like electrical vehicles, the same things. If you have too much of them, the grid is suffering. If grid is not prepared, the same thing is also with photovoltaics. But unfortunately, I don't see at the market any kind of significant progresses, at least on the scale that, you know, when you come to the company that is selling PVs to offer you some solution to create this kind of flexibility.
Okay, thank you. Good morning. Thank you very much and congratulations for this great presentation and a very wide view about the PV. My question goes on to the economics of solar PV. Very commonly use the levelized cost of electricity to compare technologies, but I think there is a handicap on this index because electricity does not have the same value anytime. And this is related with the previous comment of Neven. So electricity is much more valuable if it is generated when it is needed.
Yes.
And levelized cost of electricity does not account for that. So do you see any more interesting index to compare technologies? Because there are other costs that are embedded in solar PV, like balancing costs and investment into the grid. So that would be my question.
Thank you for question. I don't have anything smart to add because you have already tackled the issue. Usually we are comparing like traditional LCO because it is like the most common. And when you have, especially if you have studies that have previously done on the same way, then you would like to compare something which is on the same way. But I can sign what you have said. I think that this point, what you said with electricity, and when electricity is needed, then we are not able to speak about the price. So this is something that should be considered, but let's see how research community will respond, because it's more matter of economics. Okay. Thank you.
Thank you very much. Over here. Professor.
Thank you.
Excellent presentation. Very much enjoyed it.
Thank you.
We had a conversation, we were talking about nuclear power, about having a dual purpose in helping reduce the costs, as was mentioned. And one novel approach that I've seen happening in Toronto, Canada, was when they had to replace the balconies in apartments. Instead of replacing them like for like, they decided to replace them with solar panels. So this was a vertical application. Have you seen similar applications where they can not only provide the electricity, but provide another purpose, maybe totally outside of electricity, but help drive down the cost?
Usually, when you have this kind of configurations that then we are trying to install not just photovoltaics, but photovoltaic thermal to have double active purpose to produce thermal power output and also to produce electricity. Of course, when you have straight photovoltaics, you are never able to achieve this kind of performance while you have, tilt angle or some optical angle. But on the other side, if you are using this configuration, so producing of hot water plus electricity, then you have two, let's say, useful outputs. So how I see the things, I would rather like to install PVT in this kind of situation than, to go just to straight photovoltaics. But my recent experience with Canada, because I was May in Vancouver visiting University of British Columbia, and it's quite costly. Photovoltaics in Canada are quite costly when compared to the Europe. So I have one question for you, since you originate from Toronto. What is the cause for this?
I don't have a hard number for you.
Mhm.
Sorry. I'm sorry, I don't have a hard number for you. We are doing a project today, and I'll have, it'll be installed in early 2025, and so I'll have some hard numbers. So I'm sorry, I can't give you a direct number. The point I was trying to make is not so much a dual use of the solar panel, but they're using the solar panel as a barrier. So they had to replace that anyways, and that's a
Okay.
dual purpose. So,
Okay,
but your point's well taken, and I can try and find out that information for you.
okay, thank you.
Can you show the second row, please? Here and then.
Thank you for the presentation, very detailed presentation. I have a question pertaining to the land use, the messaging around the land use and the toxicity of PV panels. When we put it into perspective with land use of other stuff we do as humans, like energy crops or coal mining, all that other stuff, are we being morally responsible when we bring up land use and toxicity in our messaging when it comes to solar panels?
Okay, if we speak about food, if we speak about food safety, then we can raise this question, is this moral? But on the other side, you need to have electricity, because nowadays we are all stuck in the cities, you are not anymore to expect that people will go back to the village and to do some, traditional life. So this is something what I have raised as question on the way, that it needs to be considered and carefully taken into account. But at the end of the day, it depends from country to country. Each country has got specific production of specific food, so it is importing, so it needs to be balanced. It's not easy to say if this is morally good, or not. Like, we can also speak about pork fat. Pork fat is food, but after 1 year it become waste. So it's something which is tricky to answer. Okay, but I think that we should not be so strict. We should be very open. Each case is specific. Even a region of countries specific, and this is my message.
Thank you. Here and then one final question back there.
Thank you. This is Bilal Kılkış from Turkey, Austin Technical University.
Thank you.
Before my question, I have a very short note about Federal Aviation Administration, FAA, regarding the airports strictly limiting the land use for photovoltaics around the airports due to pilots' glare risk. And for example, in the airport of Denver, they spent millions of dollars for photovoltaics around the airport, and they are now closed by cloth because it was against the rules. So my question is, first of all, I would like to thank you, especially for your dedicated time for PVTs. This is a very important issue, but unfortunately, to the best of my knowledge, there is no any national or international standards just to directly and specifically test PVTs. Again, to the best of my knowledge, they just test in the PV labs, and they just indirectly test the thermal power output and its efficiency. And as a last note, PVT companies, which are especially in France, there are companies, but they just claim that their efficiency is 80% simply by adding thermal power efficiency with electrical power efficiency. Actually, it is one is apple, the other one is orange.
Yes.
So you cannot add them up. Thank you.
Thank you.
No?
So regarding the PVT, as far as I know, I didn't met any standards for production or so it all depends from company to company. Company is producing, putting on the market, and that's it. Yes. But regarding this last point that you said, efficiency, yes, you are right. Majority, even researchers, when they are putting efficiency, they are putting the highest number during the peak times, and they are summarizing electricity plus thermal, but it needs to be, separated. But what I would like to see, let's say, smart PVT systems who are able to respond, on the way. Okay, now we need more thermal power output, or we need more electricity, and to have this kind of flexible system. But it's not easy, but it is a message for young colleagues for PhD to try to think how we can produce a more flexible PVT system in that sense. Thank you.
Thank you. So last question, in the show, please. Thank you.
Great presentation. I missed some reflections on the embodied energy, CO2 emissions from production, transport, and installation. Any reflections? Thank you.
So you are asking about embodied energy in regarding the LCA analysis. This is something which, of course, I have stated that production of photovoltaics is linked with high energy consumption and also with high demand for water because of specific production processes. But when you look, overall as a whole, when you compare, with other technologies, I think that still photovoltaic technologies have overall positive outcome. I'm more concerned about environmental issues. This is which is again linked with your question, what you have asked.
All right, time is up. I had several questions.
We
but
can continue.
Yeah, I was gonna say, if you had more questions, we can continue during lunchtime. I have several questions for you, but hopefully
okay.
we can continue next. So I want to thank Professor Nižetić for the interesting presentation, and I hope you enjoyed. And yeah, lunchtime now. Thank you so much.
Thank you.